Astronomy 101, Frontiers in Astronomy, is really an overview of astronomy itself. It is a course that can give a broad overview of astronomy but does not dig overly deep into any of its topics. And what topics are we concerned about? Astronomy can be defined as the scientific study of the universe and the objects in it, including stars, planets, nebula, and galaxies. Astronomy deals with the position, size, motion, composition, energy, and evolution of celestial objects. Those that work in the field of astronomy are called astronomers. Astronomers analyze not only visible light, but also radio waves, X-rays, and other ranges of radiation that come from sources outside the Earth's atmosphere. They use our understanding of physics and chemistry to provide an understanding of those objects which sent us that electromagnetic radiation, the generic phrase for that collection of radiation types. The first unit of this course specifically tries to address the following course competencies listed for this course. 1. Interpret motions of the sun, moon, stars, and planets as viewed from Earth's surface and from an inertial reference frame. 2. Describe our understanding of the cosmos in historical context from ancient times through Copernican revolution. 3. Describe some basic properties of light and recognize the different wavelength regimes of the electromagnetic spectrum. And 4. Distinguish among the designs and performance characteristics of different types of telescopes. The 4 chapters assigned to this unit, the homework assigned from those chapters, the quizzes for each of those chapters, and the unit test, as well as the 2 observation logs, attempt to prepare you for those course competencies. Successful completion of these readings and assignments should make you comfortable addressing that which those competencies address. The 2 observation logs explicitly address the first competency concerning the interpretation of the motion of the sun, moon, stars, and planets as viewed from Earth's surface. You are literally going to be making observations and hopefully draw conclusions from those observations, consistent with what is introduced in the first 2 chapters of this text. In essence, you will be doing some rudimentary science, making observations, matching those up with working hypotheses, and drawing conclusions. Of course, this means you actually need to go outside and make those observations and keep good notes of what you see, so that you can draw valid conclusions. Chapter 1 gives an overview of the course and our place in the universe. It also introduces things like scale, units, and the scientific method, all tools for any scientist, and especially astronomers. You will read of what can be seen at different scales within our solar system and beyond, so that you might appreciate a bit more what is covered in later chapters. Chapter 2 looks at patterns that have been observed in the sky since ancient times, patterns that have driven our increased understanding of the universe and our place in it. You will read of early models that attempted to explain some of those patterns, initially centered on our own planet Earth. But you will also read that as observations got better, flaws began to show up that forced the consideration of better models. Chapter 3 introduces what is generally referred to as the Copernican Revolution. This was a revolution of ideas, not the warlike revolutions within and between countries that was also happening during this same time period. Copernicus introduced a sun-centered or heliocentric model, which was in some cases better at explaining the observed patterns in the sky, though in its initial rendition still a bit flawed. Later contributions to the positive changes of the model included Kepler and his 3 laws of planetary motion, moving the model from circular orbits to elliptical orbits, displacing the sun from the center to one of the 2 foci of the elliptical orbits. Along with relationships between distances from the sun to the known planets and the timing of the orbits, Kepler made headway, though there still lacked an overall cause to these effects. Galileo made telescopic observations and showed that Keplerian ideas must be superior to those of an Earth-centered model, providing the observational proof to support the heliocentric thinking, a hallmark of good science in general. Observational support always bests gut feelings and is the basis of critical thinking, something that is hoped all students leaving this and other science courses develop over time. Adding the finishing touches to the Copernican revolution, though by no means is the revolution itself over, was Newton. His three laws of motion, coupled with his law of gravity, provided the framework justifying the three laws of planetary motion Kepler discovered. They provide the cause to the effect, if you will. Newton's laws have broad applications not only here on Earth, but beyond our Earth, and helps to provide a framework for understanding the motions observed of objects in our universe. Chapter 4 looks at light and its various forms. Not only what we think of when we hear the word light, but other types of light, more correctly called electromagnetic radiation. Astronomers analyze these different types of electromagnetic radiation to get deeper understanding of those objects sending it. Understanding the properties of electromagnetic radiation and the circumstances that can lead to the formation of different types comes from studying spectra, for example, which takes that radiation and spreads it out over wavelength, frequency, and energy, all of which are related. To gather as much electromagnetic radiation from an object as possible, different types of telescopes are used. Telescopes specifically designed to gather that specific range of radiation. Some telescopes look like the traditional ones we think of when we hear the word telescope. Others look nothing like what we might think a telescope should look like, but serve the same function, both on the Earth and in space itself. In summary, one can consider these 4 chapters as providing a framework and a tool set for trying to understand the universe and that which makes it up. From the planets of our solar system and the natural satellites that orbit them, to the sun and the other stars, to the galaxies made up of those stars, and ultimately the vast collectives of those galaxies, the human mind has been on a journey of discovery. And it is in this course that you can get a taste of what that journey has been like and what we have discovered so far.